Okay, so I have started recording, so we can go ahead and get started. Today, what we're going to do is go through a few videos. We're starting some topics in statistics. And so I thought the best way to do this is to go through a few videos and then go through a few problems in Newton for each topic here. And that's going to be it. And I'm going to record everything. So like I said earlier, if you do have to leave, feel free to do so. And you can always come back and watch this video later. And even when you watch it later, just keep in mind that you don't have to watch everything at one time. So you can watch a little bit, pause, stop it, and then come back later. And then each individual video, I'm going to send out also. So you'll have everything you need to start working on these new topics in Newton. So today, the first topic is finding the mean, mode, and median of a data set. The second video is finding the mean from a frequency table. Third video, this thing called the 5-number summary. What is it and how to calculate it? The next one is how to draw a box and whisker plot. Next one, finding percentile and quartile from a set of data. And then how to find outliers of a data set. So let me get up the first video, how to find the mean and mode of a data set. And you see the words math antic? Just want to check. Okay, good. All right.
Hi, this is Rob. Welcome to Math Antics. In this lesson, we're going to learn about 3 important math concepts called the mean, the median, and the mode. Math often deals with data sets, and data sets are often just collections or groups of numbers. These numbers may be the results of scientific measurements, or surveys, or other data collection methods. For example, you might record the ages of each member of your family into a data set. Or you might measure the weight of each of your pets and list them in a data set. Those data sets are fairly small and easy to understand, but you could have much bigger data sets. A really big data set might contain the cost of every item in a store, or the top speed of every land mammal, or the brightness of all the stars in our galaxy. Those data sets would contain a lot of different numbers, and if you had to look at a big data set all at one time, it would be pretty hard to make sense of it or say much about it besides, well, that's a lot of numbers. But that's where mean, median, and mode can really help us out. There are 3 different properties of data sets that can give us useful, easy to understand information about the data set so that we can see the big picture and understand what the data means about the world we live in. That sounds pretty useful, huh? So let's learn what each property really is and find out how to calculate them for any particular data set. Let's start with the mean. You may not have ever heard of something called the mean before, but I'll bet you've heard of the average. If so, then I've got good news. Mean means average. Mean and average are just 2 different terms for the exact same property of a data set. The mean, or average, is an extremely useful property. To understand what it is, let's look at a simple data set that contains 5 numbers. As a visual aid, let's also represent those numbers with stacks of blocks whose heights correspond to their values. 1, 8, 3, 2, 6. Right now, since each of the 5 numbers is different, the stacks of blocks are all different heights. But what if we rearrange the blocks with the goal of making the stacks the same height? In other words, if each stack could have the exact same amount, what would that amount be? Well, with a bit of trial and error, you'll see that we have enough blocks for each stack to have a total of 4. That means that the mean, or average, for our original data set would be 4. Some of the numbers are greater than 4, and some are less. But if the amounts could all be made the same, they would all become 4. So that's the concept of the mean. It's the value you'd get if you could smooth out or flatten all of the different data values into one consistent value. But is there a way that we could use math to calculate the mean of a data set? After all, it would be very inconvenient if we always had to use stacks of blocks to do it. There's got to be an easier way. Oh, man. To learn the mathematical procedure for calculating the mean, let's start with blocks again. But this time, instead of using trial and error, let's use a more systematic way to make the stacks all the same height. This way involves a clever combination of addition and division. We know that we want to end up with 5 stacks that all have the same number of blocks, right? So first, let's add up all of the numbers, which is like putting all of the blocks we have into one big stack. Adding up all of the numbers, or counting all the blocks, shows us that we have a total of 20. Next, we divide that number, or stack, into 5 equal parts. Since the stack has a total of 20 blocks, dividing it into 5 equal stacks means that we'll have 4 in each, since 20 divided by 5 equals 4. So that's the math procedure you use to find the mean of a data set. It's just 2 simple steps. First, you add up all the numbers in the set, and then you divide the total you get by how many numbers you added up. The answer you get is the mean of the data set. Let's use that procedure to find the mean age of the members of this fine-looking family here. If we add them all up using a calculator, or by hand if you'd like, the total of the ages is 222 years. But then, we need to divide that total by the number of ages we added, which is 6. 222 divided by 6 is 37. So that's the mean age of all the members in this family. Alright, that's the mean. Now what about the median? The median is the middle of a data set. It's the number that splits the data set into 2 equally sized groups or halves. One half contains members that are greater than or equal to the median, and the other half contains members that are less than or equal to the median. Sometimes finding the median of a data set is easy, and sometimes it's hard. That's because finding the middle value of a data set requires that its members be in order from the least to the greatest, or vice versa. And if the data set has a lot of numbers, it might take a lot of work to put them in the right order, if they aren't already that way. So to make things easier, let's start with a really basic data set that isn't in order. It's pretty easy to see that we can put this data set in order from the least to the greatest value just by switching the 2 and the 1. There, now we have the data set 1, 2, 3, and finding the median or middle of this data set is easy. It's just 2, because the 2 is located exactly in the middle. That almost seems too easy, doesn't it? But don't worry, it gets harder. But before we try a harder problem, I want to point out that sometimes the mean and the median of a data set are the same number, and sometimes they're not. In the case of our simple data set, 1, 2, 3, the median is 2, and the mean is also 2, as you can see if we rearrange the amounts or follow the procedure we learned to calculate the mean. But what about the first data set that we found the mean of? We determined that the mean of this data set is 4, but what about the median? Well, the median is the middle, and since this data set is already in order from least to greatest, it's easy to see that the 3 is located in the middle, since it splits the other members into 2 equal groups. So for this data set, the mean is 4, but the median is 3. So to find the median of a set of numbers, first you need to make sure that all the numbers are in order, and then you can identify the member that's exactly in the middle by making sure there's an equal number of members on either side of it. Okay, so far so good. But some of you may be wondering, what if a data set doesn't have an obvious middle member? All of the sets we've found the median of so far have an odd number of members. But what if a set has an even number of members, like the data set 1, 2, 3, 4? There isn't a member in the middle that splits the set into 2 equally sized groups. If that's the case, we can actually use what we learned about the mean to help us out. If the data set has an even number of members, then to find the median, we need to take the middle 2 numbers and calculate the mean or average of those 2. By doing that, we're basically figuring out what number would be exactly halfway between the 2 middle numbers, and that number will be our median. For example, in the set 1, 2, 3, 4, we need to take the middle 2 numbers, 2 and 3, and find the mean of those numbers. We can do that by adding 2 and 3, and then dividing by 2. 2 plus 3 equals 5, and 5 divided by 2 is 2.5. So the median of the data set is 2.5. Even though the number 2.5 isn't actually a member of the data set, it's the median because it represents the middle of the data set and it splits the members into 2 equally sized groups. Okay, so now you know the difference between mean and median, but what about the mode of a data set? What in the world does that mean? Well, mode is just a technical word for the value in a data set that occurs most often. In the data sets we've seen so far, there hasn't even been a mode because none of the data values were ever repeated. But what if you had this data set? This set has 6 members, but some of the values are repeated. If we rearrange them, you can see that there's 1 1, 2 2s, and 3 3s. The mode of this data set is the value that occurs most often or most frequently, so that would be 3 since there's 3 3s. Now don't get confused just because the number 3 was repeated 3 times. The mode is the number that's repeated most often, not how many times it was repeated. As I mentioned, if each member in a data set occurs only once, it has no mode. But it's also possible for a data set to have more than one mode. Here's an example of a data set like that. In this set, the number 7 is repeated twice, but so is the number 15. That means they tie for the title of mode. This set has 2 modes, 7 and 15. Okay, so now that you know what the mean, median, and mode of a data set are, let's put all that new information to use in one final real-world example. Suppose there's this guy who makes and sells custom electric guitars. Here's a table showing how many guitars he sold during each month of the year. Let's find the mean, median, and mode of this data set. First, to find the mean, we need to add up the number of guitars sold in each month. You can do the addition by hand or you can use a calculator if you want to. Either way, be careful since that's a lot of numbers to add up and we don't want to make a mistake. The answer I get is 108. So that's the total he sold for the whole year. But to get the mean sold each month, we need to divide that total by the number of months, which is 12. 108 divided by 12 is 9. So the mean, or average, is 9. Next, to find the median of the data set, we're going to have to rearrange the 12 data points in order from smallest to largest so we can figure out what the middle value is. There, that's better. Since there's an even number of members in this set, we can't just choose the middle number. So we're going to have to pick the middle 2 numbers and then find the mean of them. 9 and 10 are in the middle, since there's an equal number of data values on either side of them. So we need to take the mean of 9 and 10. That's easy. 9 plus 10 equals 19, and then 19 divided by 2 is 9.5. So the median number of guitars sold is 9.5. That means that in half of the months he sold more than 9.5, and in half of the months he sold less than 9.5. Last of all, let's identify the mode of this data set, if there is one. Well, let's see. There's 2 8s in the data set. Oh, but there's 3 10s. That looks like the most frequent number. So 10 is the mode of this data set. It's the result that occurred most often. All right, so that's the basics of mean, median, and mode. There are 3 really useful properties of data sets, and now you know how to find them. But sometimes the hardest part about mean, median, and mode is just remembering which is which. So remember that mean means average, median is in the middle, and mode starts with MO, which can remind you that it's the number that occurs most often. Remember, to get good at math, you need to do more than just watch videos about it. You need to practice. So be sure to try finding the mean, median, and mode on your own. As always, thanks for watching Mathantics, and I'll see you next time. Learn more at mathantics.com.
Oops. Okay. All right, everybody. That is video number 1. Let's see. The next one is we want to find the mean from a frequency table. And again, just to remind you, we're going to go through all videos first and then go into Newton and then work out the problems. And then each video that you're watching, I'm going to send that out as an individual link also when everything is done. But overall, what did you think of that video with Rob and how he explained mean, median, and mode? You all.
It was insightful.
Okay. Okay.
Yeah, it actually helped.
Good. 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 Okay.
The table below shows the scores of
And you all can see where it says the table below shows the scores of a group of students on a 10-point quiz.
Yes.
Yeah.
Okay, good. All right, here we go.
The table below shows the scores of a group of students on a 10-point quiz. Notice how the information is given as a frequency table, where the first column are the test scores, the second column gives the frequency of each test score. We want to determine the mean score as well as the median score. So for a review, let's start with the mean. The mean of a set of data is the sum of the data values divided by the number of data values. And sometimes we'll see the formula for the mean written here, where x bar, the mean, is equal to the summation of x divided by n, where the summation of x is a
Don't worry about this formula. I know this looks kind of whatever, but he's just saying you add up all the numbers. That's the numerator. And then you divide by the number of numbers. That's n. He's just using different math notation. That's all. All right.
sum of the data values, and n is the number of data values. So going back to our frequency table, let's first determine the number of data values by summing these frequencies. If we sum this column here, we get 19, which means there are 19 test scores. And therefore, to find the mean, which we'll label x bar, we want to find the sum of the 19 test scores and then divide by 19. Instead of writing out all 19 test scores, though, let's look at how we can use multiplication to help us find the sum of these test scores. Because the test score of 3 has a frequency of 2, there are 2 test scores of 3, which is the sum would be 3 plus 3. But we can write 3 plus 3 as 2 times 3, since we have 2 3's. Of course, we could also write this as 3 times 2. Notice the test score of 4 has a frequency of 4, so if we wanted to find the sum of these test scores, we could write out 4 plus 4 plus 4 plus 4. It would be much faster to just write 4 times 4, since we have 4 4's. So we could find the sum of products to determine the total sum, rather than writing out 19 data values. Let's go ahead and do it this way instead. So 3 has a frequency of 2, so we'd have 2 times 3, plus 4 has a frequency of 4, so 4 times 4, plus 5 has a frequency of 2, so plus 2 times 5, plus both 6 and 7 have a frequency of 1, so we could just write plus 6 and plus 7, but to keep the pattern, let's write 1 times 6 plus 1 times 7, plus 8 has a frequency of 3, so 3 times 8, plus 9 has a frequency of 5, so we have 5 9, so 5 times 9, plus 10 has a frequency of 1, so we'd have 1 times 10. The sum of these products would give us the sum of all 19 data values. And now let's go to the calculator to determine the mean. We'll put the numerator in parentheses, open parenthesis, 2 times 3 is 6, plus 4 times 4 is 16, plus 2 times 5 is 10, plus 1 times 6 is 6, plus 1 times 7, plus 3 times 8, that's 24, and then we have plus 5 times 9 is 45, finally plus 1 times 10 is 10, close parenthesis, divided by 19. So the mean is approximately 6.5 to 1 decimal place. And now let's determine the median. For review, the median of a set of data is the value in the middle when the data is in order. So to find the median, we begin by listing the data in order from smallest to largest or largest to smallest, which in our case has already been done. So next, if the number of data values n is odd, which is our case, then the median is the middle data value. This value can be found by rounding n divided by 2 up to the next whole number. Notice in our book, they're using capital N rather than lowercase n, but either way, n represents the number of data values. If the number of data values happens to be even, which is not our case, there is no middle value, so we find the mean or average of the two middle values, which would be n divided by 2 and n divided by 2 plus 1. Again, in our case, we're going to find n divided by 2 and round up to the next whole number. So n divided by 2 would be equal to 19 divided by 2, which equals 9.5. So rounding up to the next whole number would be 10, which means the median is the 10th test score, starting at either the lowest test score or the highest test score. So we'll use a frequency to count down to the 10th test score. So adding the frequencies, 2 plus 4 is 6, plus 2 is 8, plus 1 is 9. So 6 would be the 9th test score, but we're looking for the 10th test score, so if we add one more, which would be 10, notice the 10th test score is 7, which means 7 is the median.
Stop right there. Any questions about that? How he's doing the calculations, you all? And I know, like I said, you'll have access to this video and you can go back and watch it again. But just want to find out, is what he's doing, it doesn't make sense.
Yes.
Okay.
Looking at the frequencies, notice how there are 2 plus 4 plus 2 plus 1, or 9 test scores below 7, and there are also 3 plus 5 plus 1, or 9 test scores above 7, verifying that 7 is the median. Okay, I hope you found this helpful.
All right. The next video is what is the 5-number summary?
This is Stephanie from This is Stephanie from statisticshowto.com, and in this tutorial I'll be showing you how to find a 5-number summary for a set of data. 5-number summary is the minimum, the maximum, the median, and two numbers called Q1 and Q3, which are the first quartile and the third quartile. I'll show you what those are in a moment. Let's start off with a set of data. Just going to choose a few random numbers here. Say you're given this set of data and you're asked to find the 5-number summary. Step 1, you want to put these numbers in order. So we've got 1, 2, 3, 5, 10, 20, 31, 42, 44, 53, and 67. So those are from smallest to largest. The minimum is just going to be your smallest number here. There's our min. And the maximum is going to be your largest number. Next we want the median. The median is the number bang in the middle. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 11 numbers, so the 6th number is going to be exactly in the middle. So 20 is going to be our median. Next we're going to find Q1. You can think of Q1 as being in the lower set of numbers below the median. So I'm going to put a parentheses around here just to show you this is the lower set of numbers below the median. And the median of this set of numbers, the number right in the middle, is the number 3. So this is our Q1. And we're going to do the same for the upper set of numbers to find Q3. We have 5 numbers. 44 is right in the middle. That's our median of our upper set of 5 numbers. and this is going to be Q3. That's how to find a 5-number summary. This is Stephanie from statisticshowto.com. Thanks for checking in.
Okay, that's it for the 5-number summary.
What? Still searching YouTube for math help? Are the videos from 2006 real?
Welcome.
Okay, next video is how to draw a box and whisker plot.
The following is a selected video. The following is a selected video from yourteacher.com, where you can browse over 450 complete math lessons with example videos, interactive practice problems, self-tests, and more. Try a complete lesson today at yourteacher.com.
A box and whisker plot is another way to display data. You'll need to remember what we learned about medians in the last section in order to draw box and whisker plots. To draw a box and whisker plot, begin by writing the data set from least to greatest. Here, notice that our data set is already written from least to greatest. Next, we find the second quartile, which is the median of the entire data set. Remember that the median is the middle number when the data is written from least to greatest. Since this data is already written from least to greatest, then the middle number, or 8, will be the second quartile. Next, we find the first and third quartile, which are the median of the lower half of the data set and the median of the upper half of the data set. Let's start with the first quartile, which is the median of the lower half of the data set. Again, the median will be the middle number, so here the median of the lower half of the data set is 6, which means that the first quartile is 6. Now, let's find the third quartile, or the median for the upper half of the data set. The median will be the middle number, or 9, so the third quartile is 9. Now, notice that the least number in the data set is 2, and the greatest number in the data set is 11. Now we're ready to make our box and whisker plot. First, draw a number line. Then, draw vertical line segments at the first, second, and third quartile. So here, at 6, at 8, and at 9. Then, connect the vertical line segments to create a box. Finally, we connect the least number, 2, to the box with a line segment, and the box to the greatest number, or 11, with a line segment, and these line segments will be the whiskers. So this box and whisker plot represents the data set shown here.
Good grammar and spelling.
Okay, so that is the video on box and whisker. And we'll go through a problem in Newton where we have to do that. It'll make more sense. Next video is finding percentile and quartile from a set of data.
For this lecture, I'm going to be talking about organizing data into percentiles and quartiles. But first of all, I want to talk about percentages. Imagine we have a data set like this, very simple, 1, 2, 3, 4, and 5. I could ask you a question like, how many numbers are even? Well, it's pretty obvious. The 2 and the 4 are even. But we could make that into a percentage. A percentage is basically the number of things meeting the characteristic of interest divided by the total number of observations times 100. So that might sound kind of weird, but let me show you this. The characteristic of interest is even. There are 2 even numbers divided by 5 total observations. So 2 divided by 5 times 100 is 40. We could say that 40% of the numbers in this data set are even, and that would be a percentage. Now, a percentile is a value below which a certain percentage of the observations lie. So let me show you what that means. Here's a longer data set. It goes from 2 to 3 all the way up to 11, 12. Now, I could ask you, what is a percentile ranking of 10? So we have 10, and basically I want to know what percentage of scores lie below that. So all these things that I have here in blue are scores that are below 10. So for the question of what is percentile ranking of 10, we can use this equation. The percentile ranking of any value is equal to the number of values below that value divided by the total number of values in the set times 100. So there are 16 blue numbers below 10, and there are 20 total numbers. So 16 divided by 10 times 100 is 80%. The percentile rank of the value 10 is 80% because 80% of the scores lie below it. So now we can kind of work backwards. What value exists at the percentile ranking of 25%? So we're asking basically what score has 25% of the scores below it. So we can use this equation to find out what value number is basically the percentile divided by 100s multiplied by the sample size plus 1. So we're interested in the 25th percentile, so I do 25 divided by 100 times 20 plus 1 because we have 20 scores. And when I work all that out, I get a value of 5.25. But that doesn't really make any sense. I mean, there could be a 5th value or a 6th value, but there is no 5.25th value. So if you end up with something like that that isn't a whole number, you can just take the average of, in this case, the 5th and the 6th. And whatever that average is, that is what exists at the 25th percentile. So my 5th number is 5, and my 6th number is 5. So the average of those two numbers, the mean of those two numbers is obviously 5. So for the question, what value exists at the percentile ranking of 25%, the answer is 5. Now, one more quick thing, quartiles is pretty simple. Imagine you have your data organized into a line like this. 25% represents the first quartile, 50% represents the second quartile, and 75% represents the third quartile. So if anyone is talking about quartiles, that's really what they're talking about. They're just talking about these 3 different percentile rankings. And that's it for this lecture. Understand what percentiles are, what quartiles are, and what percentages are.
There is a shortage.
Wow, that was deep in vocabulary, but we will work out problems in Newton to help make this stuff a little more clear. Not a little more, hopefully a lot more. Math is like a lot of other subjects, you all. It's vocabulary. Okay, what in the heck what were they saying, and what does it mean? So don't get turned off by the words that they're using. You want to work to make sure that you understand what the vocabulary is, what it means, and then how to work out the problem. Okay, last video. how to find outliers in a data set. So once we watch this one, I'll bring up problems in Newton and we'll start working through. Okay, it's only 11:40. Okay, about 40 minutes. Yeah.
In this video, we want to identify outliers in a set of data. If you're not sure what an outlier is, here's what they are. An outlier is an extremely high or extremely low value in the data set. Now, in addition to just being something really high or something low, you want to make sure that it satisfies the following criteria. If you want to find an outlier, it must be greater than Q3 plus 1.5 the interquartile range, or it must be lower than Q1 minus 1.5 times the interquartile range. This is making sure that it really is an extremely high value or extremely low value. You can see though that we need to compute a few different things like Q3 and Q1 and the interquartile range if we're going to properly identify one of these outliers. So let's look at some data and see how this works. In my data, I have a chart of maybe how many phone calls were received on any given day. So I got 10 phone calls on the first day, 12 phone calls on the second day, and so on and so forth. If I'm going to compute things like Q1, Q3, and the interquartile range, it's probably a good idea to take all of this data and write it out in order. 10, 11, 11, 11, 12, 12, 13, 14, 14, 15, 17, 22. All right, so you can see that when I list out my data like this, 22 does look like a pretty high value, and 10 looks like a fairly low value. To double check that one of these might be an outlier, or maybe both of them, let's go ahead and start breaking down our data to find Q1 and Q3. So I want to find the halfway point of my data, and I have 12 data points, so 1, 2, 3, 4, 5, 6. All right. So I need the mean of the first half and the mean of the second half. Let's see, the halfway point of the first half, let's call this Q1, and looks like that is equal to 11.
And that Q1 is the same thing as the first quartile. So think of like the little one is first and then Q for quartile. And then he's going to find Q3, which is the third quartile. That's what was the terms used in the previous video.
Remember, you find that by adding 11 plus 11, dividing by 2. Point of the first half, let's call this Q1, and looks like that is equal to 11. Remember, you find that by adding 11 plus 11, dividing by 2. The mean of the second half, this would be 14 and a half. All right, now to find our interquartile range, we would end up subtracting these two values from one another. This would give us 3 and a half. All right, we have all of the information we need. Now we can figure out other values, so we can figure out outliers. So to look for an extremely high value, it must be larger than Q3, which is 14 and a half, plus 1.5 times the interquartile range, 3.5. And to find an extremely low value, I would take Q1, 11, and I would minus 1.5 times the interquartile range. Let's see what these equal. 19.75. And 5.75. All right, so here's how this works. If I have any data points that are larger than 19.75, they're an outlier. And if I have any data points that are smaller than 5.75, those are outliers. Well, looking at all of our data, we can see that the 22 is definitely larger than 19.75, so it's definitely an outlier. Unfortunately, I have nothing less than 5.75, so I don't have any lower outliers. So this entire set of data only has one outlier, and it's just the 22. So it's definitely an extreme value. So remember that you got to find a few different bits of information first, but this is how you go about finding your outliers.
Why aren't you the landlord?
I'm not a landlord. Okay. All right, that's it for the videos. Let me bring up the problems in Newton, and we'll work through and answer any questions that you all have or may have. Okay, Marcos, did you see the line I just drew, the stuff I'm drawing, and where it says find the mean given a list of numbers?
Yes.
Okay, okay. So our first problem is to find the mean given this list of data. So it says given the following list of numbers, find the mean. So we have the numbers 3, 9, 10, 2, 3, 9, 10, 2, 10, and 8. So the first thing we want to do is we're going to find the sum. You know what? I can say it better than that. Add all the numbers. Add all numbers, which is what they did down here. And when you add all your numbers, you get the sum of 42. Second thing you want to do is divide by the number of numbers. Divide by number of numbers. Well, since we had 6 numbers here, we're going to divide by 6 here. And then 42 divided by 6 is going to give me 7. So my mean is 7. Okay, so that's it for our first example. We had to find the mean or find the average just given a list of numbers. So any questions about that?
No, it's very straightforward.
Okay. Okay. And just a reminder, when I send out the video that we're recording now in Zoom, I'll have all the video links that for the videos we just watched, and then this Word document that has the problems. worked out already. I'm going to send that out also. Just trying to think of everything I can give you all to help you as you're working through these problems in Newton. So feel free when you are working through Newton, you can go back and have the video open, watch it a little bit, then work through a problem in Newton. So it's not like you have to just totally watch the video and then just work the problems. Use everything that you have at your disposal to help you out. Okay, so for number 2, we want to find the mean given a frequency table. So here is the frequency table. And I did include the answer explanation here. But what we want to do is multiply. So to find the mean, multiply the value times its frequency. And frequency means how many times does that number appear in a data set. So a value of 10 appears 7 times. So I would have 1, 2, 3, 4, 5, 6, 7 tens. Then the number 11 appears twice. So 11, 11, and so forth, all the way down to the number 17 appears 1 time. So you would multiply, okay, to find the mean, multiply the value times the frequency. So 10 times 7 equals 70. 11 times 2 is 22. 12 times 1 equals 12. 3 times 3. 13 times 3 is 39. 14 times 1 is 14. 15 times 6 is 90. 16 times 3 is 48. And 17 times 1 is 17. So scrolling down here, this is what they did right here. And when you add all those together, you get 312. Now, right here, it says the number of numbers in the list is the sum of the frequencies. So that means when we add up all these numbers, it's going to give us our denominator of 24. So adding up all the frequencies, we get 24. So to find the mean, we've got the sum divided by the number of numbers. Well, that's 312 divided by 24, which equals 13. And that is how you find the mean given a table like this, where you have the value and the frequency, which means how many times the number appears in the data set. Aaron, Marcos, any questions about that?
No, it makes sense.
Okay. And Chloe, sorry. I cannot see all the names, so if I don't call your name, I apologize in advance. Right now, I just see Chloe's name. Okay. All right, next, number 3, we want to find the mean given a range of data values. Well, this is similar to the last one, except for one thing. Here, you notice that the values, it's a range. So we have the ranges 2 to 5, 6 to 9, and then 10 to 13. So we need to find the average first. So on average for each value interval. So for the interval 2 to 5, well, to find that average with 2 plus 5 and divided by 2 gives me 7 divided by 2, which equals to 3.5. So I'm going to put 3.5 right here. And then for the range 6 to 9, find that average. 6 plus 9 divided by 2 is 15 divided by 2, which is 7.5. And then for the value interval 10 to 13, find that average, 10 plus 13 divided by 2. 10 plus 13 is 23 divided by 2. Get my calculator, 23 divided by 2 equals 11.5. So now that we have the midpoints, we have the averages. Now let me move down here because this, what I just drew a square around, is right here. And then they copy down the frequency to right here. So I'm gonna pick up reading from right here. Now we treat this as if it were a regular frequency table. Take the midpoint, I'm multiplying its frequency. We add them up and then divide by the total number of values. So it's 3.5 times 11 plus 7.5 times 6 plus 11.5 times 3. And that gives us 118, which is going to wind up being the numerator. And then for your denominator, we find the total number of values by adding up the frequency column. So when we add up 11 plus 6 plus 3, that gives us 20, which becomes our denominator. And then when you divide 118 by 20, you get 5.9, which is the mean. So this was just another way to calculate the mean. Anything I need to repeat for this one? Lloyd, Marcos, Aaron?
No, I don't think so.
Okay. Okay, next up is find the median or the middle point if you're given a set of data. So here we have set of data 29, 22, 12, 13, 20, and 30. So the first thing we want to do is put these numbers in order. And now the second thing is, says because this has a length of 6, meaning 1, 2, 3, 4, 5, 6, you got 6 numbers, then the median is going to be the average of the 2 middle numbers. Write these over here. 12, 13, 20, 22, 29, and 30. Now, what I just put a box around, I have to find the average of those 2 numbers, and it's going to give me my median. And remember that the median leaves you with the same number of numbers beneath it and above it. So once I calculate this average of 20 and 22, I'll have 2 numbers to the left of the median and 2 numbers to the right of the median. So now to find the average, just add 20 plus 22 divided by 2. So 20 plus 22 is 42 divided by 2, and that equals 21. And so the median is 21. And so that is how you find the median if you're given a set of data. Okay. I'm going to erase this and go to the next problem. Okay, for number 5, we want to find the mode given a list of numbers. And the mode is the number that appears the most frequently. So they give us this set of data. And they rewrote this down here. It took each value and then wrote down how many times it occurred in the table, in this list of data right here, which is a good way to do it. So we can see that the value 12 appeared twice, 15 appeared 3 times, 16 appeared twice, 17 appeared once, and 20 appeared twice. So here 15 is the mode because it appeared the greatest number of times. Mode equals the value 15. So remember that with the mode, we had to put the numbers in order from least to greatest. And then you want to see which number appears the greatest number of times. And that's going to be your mode. Okay, next up, number 6, find the median or the middle value given a list of numbers. So we have this list of numbers here. And we want to find the median of these set of numbers. Well, it helps to put the numbers in order first, which is what they did here. Now notice that we have an odd number of numbers. It says now because the list has 7 numbers, which is odd, we know the median is going to be the middle number. So I have 5, 6, 7, 10, 19, 22, and 27. The number that is in the middle is 10. And notice again that I have 3 numbers less than the median, and I have 3 numbers above the median. This is by definition for the median. You have to have the same number of numbers below the median and above it. So 10 is the median. So that is how you find the median given a set of data. Anything else to go through? Oh, that's it. Okay, that's it for this problem. All right, number 7, find the possible outlier. Outlier meaning a number that's either a whole lot less than the rest of the numbers or a whole lot greater than the set of numbers. They give us the data in this table here. My notes. This is number 7. Uh-oh. Give me a second. I need to find something in my notes to help me out here. Well, most of the values are between 15 and 23, whereas 30 is far above the rest of the values. Therefore, no, that's not right. Yeah, right. I'm going to keep recording, but I need to work this particular problem out again. So everybody give me a couple of minutes to figure out something. Yeah, so I wrote down something that's just not making sense right now. All right. So I guess what, 5-minute break, and then what time is it now? It is 12:11. So yeah, let's pick this back up. Yeah, 12:20. Hey, give me 10 minutes. So while I do that, I don't want to stop recording because it's going to make me, can I pause it? Pause the share. Anyway, 10-minute break, and I'll see you all in 10 minutes. This is interesting. N divided by 2, and then round up. One. Six plus 10. Okay, so 1 plus 3 plus 4 plus 6 plus 10 plus 3 plus 2 plus 10 plus 3 plus 2 plus 1 plus 1 equals 31. That's the answer. Here equals 1. Then it's the frequency. So 1 plus some frequency is 31. It's going to be 1 plus 3. 8 plus 6 is 14. 17, 17, 18, 18, 19, 6. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 1, 6, 7, 16. 1, 2, 3, 4, 5, 6, 7, 8, 15 below. 6, 7, 15 above. Okay. And so 1, 2, 3, 4, 5, 6, 7, 14. 6, 18 plus 18. 1, 2, 3, 4, 5, 6. 7 is missing here. 1, 2, 3, 4, 5, 6, 12. Oh, no. All right, that's supposed to be here. One, two, three, four, five, 6, 7. Oops. And then this down to here. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7, 8. Yes, that is 18. 21. 2. 21 plus 21 divided by 2. Still. Okay, I'm going to have to come back, do a separate short video on number 7, because this just is not working out like I thought it was. So, not to prolong this video, we're going to keep it moving to the next problem. Okay, so for number 8, it tells us that the 5-number summary is given. Okay, we need to find the interquartile range, which is just Q3 minus Q1. So down here, the 5-number summary for a set of data is given. They give us the minimum. They give us Q1, the median, Q3, and then the max value. So when we subtract Q3 minus Q1, that gives us 85 minus 74, which equals 13. No, it does not give us 13. Wow, it gives us 11. Right, because 5 minus 4 is 1. And then 8 minus 7 is 1. What I'm underlining here, the third quartile minus the first quartile. This is our Q3 minus Q1 right here. All right. Number summary. Okay, the last thing we want to do is the box and whisker plot. So let me open up Newton and go through this, and that's going to be it. And I'll just do a separate video for this outlier stuff. And once that's done, I'll email that out to everybody and then post it in Canvas as an announcement. And then you'll have that to help you out. All right, last problem. Okay. And what we have here. Okay. I'm gonna have to read through this thing. Okay, data set list, number of hours. Okay, for the data set, the minimum is 1. The median is 5. The third quartile is 8. Interquartile range is 4. And the maximum is 17. So they want us to construct the box and whisker plot. Well, we can just use what they give us to construct this thing. Let's start with the median, which is 5. So what I can do is actually move. Right now, the median is set to 12, but I can move this box by left clicking on it. That's how it worked when I was practicing. Really? Okay, there it is. Moving this down to 5. So now I have my median, that is 5. Now the third quartile, or Q3, is 8. So I'm going to grab the right edge of this box and move this up from 6 to 8. Okay, so now I have Q3, the third quartile is 8. That's the right side of the box. Okay, if it tells me that the interquartile range is 4, that means that Q3, which is at 8, Q1 has to be 4 because the difference between Q3 and Q1 has to be 4. So Q1 is equal to 4. And so that's already at 4. Okay, my minimum value is 1. So I come here, left click, and bring this down to 1. And now the maximum value is 17. So left click and then drag this endpoint out to 17. And let's submit it and hope it says correct. Hooray, okay. All right, y'all, it's 12:30. You've been troopers to hang in this long, I appreciate it. Like I said, I gotta go back and work out some other problems and then record it and then send those out as a separate video. But everything you have seen today, I'm going to provide to you so you'll have it to work out. Because this work isn't due until Friday, December the 4th. So you've got a good amount of time. Yeah, good amount of time to work on this. So above all my bumbling through this stuff, any questions about anything else, yo?
I'm good. Thank you.
You're welcome, Chloe.
Yeah, I don't got anything either.
Okay. Thanks, Aaron. Y'all enjoy Thanksgiving.
Thank you.
All right, you too. Thank you so much.
You're welcome.